Hello friends, I welcome you in lecture number 8 on logic. In this lecture also we will discuss one question on determining whether given statement formula is a tautology, contradiction or contingency. We have seen this type of problems in lecture number 6 and 7 and we have used truth table to determine whether given statement formula is of particular type. So we try to answer this question also using truth table. Here statement formula is P implies Q implies R implies P implies Q implies P implies R. So this statement formula has used the logical operator implication. We know that P implies Q is false if first proposition, that is P, is true and second proposition, that is Q, is false, and in all other cases this conditional statement is true. So we are remembering in this way: conditional statement P implies Q is false if P is true and Q is false. Similarly, for all this we are going to use this definition. Suppose this is denoted by capital A, this is denoted by capital B, then A implies B is true if A not true. We remember in this way. We remember that when it is false, and in all other cases it is true. So A implies B is false if A is true and B is false. In all other cases it is true. And here we have to determine whether this is a tautology, that means this statement formula is always true, or whether it is a contradiction, that is this statement formula is always false, or contingency, that is it is neither a tautology nor a contradiction. For preparing truth table, we note that here we are having three propositions or statement formulas or statement variables P, Q and R, and using possible truth values of P, Q and R, we will be able to determine these implications: P to Q, then Q to R, then P to R, and then this left hand side, which is P implies Q to R, and this last implication, which is P implies Q, and this implies P implies R. So first we write down all possible combinations of truth values of P, Q and R, and we know that for each statement variable there are two possibilities: either it is true or false. So we are having three propositions or statement variables, therefore we consider Cartesian product of this set with itself 3 times. So this will give us all possible combinations of truth values for these variables P, Q and R. First I consider Cartesian product of these two sets, and I will have T, 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 F and F, T, F, F, and this I have to consider Cartesian product with T and F. So now I consider, first I fix T, T, and I vary T and F as third possibility, T, T, T and T, T, F. Then I write same thing for this T, F is fixed and third component is T and F. Similarly F, T, T, F, T, F, then F, F, T and F, F, F. So whenever I write T means this is for P, this is for Q, and this is for R, and similarly for all these cases. So if we see here, for P, possibilities are T, 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 that is first 4 truth values are T and last 4 truth values are F. These are the possibilities for statement variable P, that is truth value T 4 times, then truth value F 4 times. So that we can write here. We can consider this table also. I can consider this type of vertical lines so that it will look nice, and then I will write down all possible truth values for each of these columns, and finally we will decide the truth value of last column, and our decision will depend on the truth value of last column. So first I am writing for P, as we have seen here, first 4 values are T and last 4 values are F. So that I am writing for P here, T, 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 and then F, F, and F, and we have one more F, 4 times T and 4 times F. Similarly for Q also we can observe second component. Here I have T, then T, that I can write here, then F, 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 then again T, T, and F, F. So this will repeat for last 4 rows also. So now I am writing possible truth values of Q, that is T, T, F, F, then T, T, F, F, and here we can draw rows also so that it will look nice. This is first row. We will have we are having 3 statement variables P, Q, and R. Therefore possible combinations are 2 to the power 3, that is 8 possible combinations are there, and we can see that there are 8 possible truth values for P as well as Q, which we have obtained using Cartesian product. And let me extend this, so we can prepare this type of table so that we can have nice look for possible truth values. Okay, fine. Now we write for possibilities of R, that is third statement variable. Here I have T, then F, then T, and then F. T, F, T, F. So for statement variable R, we have alternately true and false. First I start with T, then F, again T and F, T and F, T and F. So these are the possible 8 combinations for truth values of P, Q, and R, which we have obtained using Cartesian product of this set with itself. And you can see it is easy to remember also. For first statement variable P, we are writing 4 times T, then 4 times F. For second statement variable T, T, then F, F, T, T, then F, F, that is 2 times T and 2 times F. And here 1 time T and 1 time F, or alternately positive and negative. Now we write down possible truth values for this conditional statement or this implication P to Q, and we know that this implication is false if P is true and Q is false. So now we check for all possible combinations of P and Q. Here P is true and Q is true, therefore this is true. Here also both are true, therefore this implication is true. Here P is true and Q is false, therefore this is false. And same thing for this row also. Now if P is false, then we consider this implication as true. So in this last 4 possibilities, P is false, therefore this implication has truth value T. So what we are using? We are using the definition of implication P implies Q. It is true, it is false if first variable is true and second variable is false. Same thing for writing truth values of this implication also. This implication is false if Q is true and R is false. So I have to take care that I look the columns for Q and R only for writing possible truth values of Q implies R. So here Q is true, R is also true, therefore this is true. Here Q is true and R is false, therefore this is false. Here Q is false. So whenever first statement is false, this implication is considered as true. So this is true. Then Q is true and R is also true, therefore this is true. Here Q is true and R is false, therefore we have false. Q implies R is false if Q is true and R is false. And here Q is false, so don't worry about R, we can directly write truth value T. Similarly, we write down possibilities for P implies R. So this is false if P is true and R is false. So now we check for P and R. So here true and true, therefore this is true. Here P is true, R is false, therefore we have P implies R is false. Here P is true, R is true, therefore this is true. Here P is true and R is false, therefore we have false. And in remaining possibilities, P is false, so we don't care about R, we directly write T. Again we have to write down this implication truth values. First variable is P, second variable is Q implies R. So now I have to observe these columns, column corresponding to P and column corresponding to Q implies R, and this is false if P is true and Q implies R is false. That is, if first one is true and second one is false. So we start with first row. Here P is true, Q implies R is true, therefore this is true. Here P is true and Q implies R is false, therefore this is false. Then P is true, Q implies R is true, therefore this is true. Same thing here, both are true, this is true. And here P is false, so we don't worry about Q implies R, we directly write that this implication is true. Then we have to check for P to Q and P to R, that is for these two columns. Again this is false if P implies Q is true and P implies R is false. So we start with first row. Here we have both are true, therefore this is true. Here this is true and this is false, therefore this is false. Here we have F for the first statement, so we directly write T here. Then this is true, so we write T here. And you can see for all the remaining combinations both are true, therefore we have true here. This is true. And finally we can write down truth values for last implication. For that we have to check for these two. P implies Q implies R and P implies Q implies P implies R. This is false if this one is true and this one is false. So we start again with first possibility. Both are true, therefore this is true. Here first one is false, so don't worry about second one, we can directly write T. And in all these remaining possibilities you can see both are true, therefore all the remaining truth values are T. And we can now see that column corresponding to this implication has all the truth values equal to T, or we can say that this statement formula is always true whatever the possibilities for P, Q and R are there, irrespective of the possible values of all these statement formulas which occur in this last formula. This is always true, therefore we can say that this given statement formula is a tautology. And this question was asked in GTU Summer 2021 exam. So finally we can write that instead of writing whole formula, we can simply write that given formula is a tautology because all the values in the column corresponding to this formula have truth value T, or this statement formula is always true and hence it is a tautology. So this is very nice question, and you can see it is very easy to determine using truth table that this formula is a tautology. So this is all about this session. I hope you like it. Thanks for watching.